Okay, 11.6 addresses cones, both the surface area and the volume. So I'm going to leave this for all of you to read on your own. And it just discusses all the different things and how they got the formula for this. So notice that this is a net for the surface area of a cone, and it helps you realize how you would measure it. This gives you all the different things you need to understand. This is a slant height, which is the outside height. The actual height of the cone is inside, perpendicular to the base. Okay, so all these things are important for you to understand, so push pause until you've read through this and can understand. Okay, so here's how you find the surface area of a right cone. And what you do is you find the pi r squared, which is the base part of it, and then you find pi r L, and L is the slant height. So those are the two things that you need to remember for the surface area of a cone. Okay, and it's a right cone only. So make sure you understand that. So finding the surface area of a right cone. So here we have it here. So we're going to go surface area equals pi, my radius is 4 squared, plus pi times my radius times 6. So that'd be 16 pi plus 24 pi, and you add those together and you get 40 pi. Okay, now that would be the final answer. Remember that surface area is in units squared because it's an area, not a volume. If you wanted to write that out, it would be approximately 125.66 inches squared. Okay, so here are a couple problems from your journal. If you want to push pause and give them a try, go ahead. So remember that the formula for the surface area of a right cone is pi r squared plus pi r L. So that means that this is my radius, this is my height, and this is my slant height. So I'm going to go r squared is 3 squared is 9 pi plus pi times 3 times my slant height, which is 5. So 9 pi plus 15 pi, and that equals 24 pi centimeters squared, or approximately 75.4 centimeters squared. Okay, so there we have a right cone, has a diameter of 1.8 and a height of 3 inches. So for this one, we have to set it up a little bit differently. So I'm going to draw you a diagram here. Okay. Now the height is this, 3 inches. Okay, so this is a right cone. That makes all the difference. My diameter is 1.8, which means that my radius is 0.9. Okay, so make sure that you differentiate between the radius and the diameter. Then I'm going to find L by using the Pythagorean theorem. So I'm going to go 3 squared plus 0.9 squared equals L squared. So I calculate that out, and I'm going to get L is approximately 3.1. Okay, so now I'm going to go back and do the other. Surface area equals pi times my radius squared plus pi times my radius times my lateral height, or you call it slant height. Okay, so now that equals 0.81 pi plus 2.79 pi, which gives me a grand total of 3.6 pi, which is approximately 11.3 inches squared. Okay, don't forget it's inches squared. All right, so go back and look at that if you need a little bit more time. But this, if you have a right cone, that is always how you can find your slant height. So that's kind of cool. Okay, now we're going to talk about the volume of a cone. With the volume, Cavalieri's principle applies. Okay, it does not have to be a right cone. So the volume of any cone is 1/3 big BH, and notice that our big B is pi r squared. Okay, so it's a cone. So it's just like a pyramid. So I want you to think of the formula just like a pyramid, 1/3 big BH. This was based on the shape. So a cone is kind of like a pyramid, only the base is always pi r squared because it's a circle. So keep that in mind. Okay, so we're going to find the volume of this cone. Remember, the surface area, it had to be a right cone. It does not matter because of Cavalieri's principle that this is not a right cone. Okay, so this is our height, this is our radius, and we are good to go. So remember that the volume of a cone is 1/3 big B h. So we're going to calculate our big B first. That's pi r squared. So that would be 2.2 squared times pi. So big B equals 4.84 centimeters squared. So now I'm going to plug that into the formula. Volume equals 1/3 times 4.84 times 4.5. I can cross cancel this and get 1.5. Either way, the volume equals 7.26 pi centimeters cubed. And that's approximately 22.81 centimeters cubed. Now, you may notice a difference between your final answers and mine after pi. I do not have a pi button on my calculator. Sometimes I use that calculator, sometimes I use the one that has a pi button, sometimes I take the answer from the book. So the difference is in where I got the answer. So if yours is pretty close to that, you are in good shape. Okay, so let's try some problems from the journal. And you can push pause here and try these on your own. Just make sure to remember that when you're doing volume, you use this height. Okay? So, first thing I'm going to look at is, I remember that volume equals big B 1/3. Don't forget your 1/3. Big B h. So my big B is pi r squared, so that's 9 pi. Okay, so I'm going to plug that in. Volume equals 1/3 times 9 pi times my height of the cone, which is 4. Okay, so that would be volume equals 3 times 4 is 12 pi centimeters cubed, which is approximately 37.7 centimeters cubed. Okay, now we're going to look at this bottom one. A right cone has a radius of 5 and a slant height of 11. So this time we're finding the volume, but we've got to do some setup first. So I want you to think it's a right cone, and they're giving us the slant height is 13 feet, and the radius is 5. So the first thing we have to find is the height. Okay, so we're going to use the Pythagorean theorem. So 5 squared plus height squared equals 13 squared. So that's 25 plus height squared equals 169. So height squared equals 144. And so our height is 12 feet. Okay, so now that we've got that, we're going to go back into here. We know that our big B is 25 pi because it's 5 squared. Okay, so pi. So we're going to go volume equals 1/3 times the big B times our height. So 1/3 of 12 is 4. So our volume equals approximately 100 pi feet cubed, which is approximately 314.2 feet cubed. Alrighty, so that one should have been really clear to you. Alright, now here's some more problems from your journal, and I put this note on the side. When you're solving problems where the given information is not the typical info, stop and think about what you've been given. Always look at the information and analyze what you have and what you need. So they're telling me it's a right cone. Okay, so I'm going to think about this, right cone. It has a surface area of 440 square inches. So I'm back to talking about surface area, and a radius of 7. Okay, and they want you to find the slant height. Okay, so first thing I'm going to do is remind myself of the formula. Surface area equals pi. They gave me the radius, so I'm going to go 7 squared plus pi times 7 times the slant height, which is what I'm trying to find. but they told me it's 440. So I'm going to go 440 equals 49 pi plus 7 pi L. Now here's where you have to be careful. So I'm going to convert this 49 pi to 153.86, and I'm going to subtract that from both sides. Okay, and I get 7 pi L. I get 286.14 equals 7 pi L. Then I'm going to divide both sides. I calculate 7 pi is approximately 21.98. So I'm going to divide both sides by 2198. And I get my slant height equals approximately 13 inches. Okay? So notice how I had to work backwards. Notice that I had to do these two things separately because of the plus sign. So be careful. Okay, so this one's talking about volume. We have a right cone. Okay, and it says that the diameter is 12, and they want you to find the height. So the first thing I'm going to do is my radius is 6. So I have volume equals 1/3 pi r squared h. So 528 equals 1/3. I'm going to multiply 6 squared, so that'd be times 36 pi times h. Cross cancel, I get 12 pi. So I'm going to divide both sides by 12 pi. Those cancel, and I get h equals about 14 meters. And there's your final answer for that. Okay, so let's look into finding. Okay, in this slide we're talking about the volume of a similar solid. So cone A and cone B are similar, and they always give you that information to start with unless they want you to find if they're similar. So notice that they have, you have to look for a part that you can compare, okay, to find the scale factor. So the first thing I'm going to do is set up my scale factor, and I'm going to do B to A. Okay, doesn't matter what you decide to do as long as you maintain that ratio throughout your problem. So I'm going to compare the radii because you have to find a linear measurement that you can compare. So the radius of B is 9 and the radius of A is 3. So that gives me a scale factor of 3. Okay, so now I'm going to use the scale factors to find the volume of B. Okay, so I'm going to again keep my ratio the same, and I'm going to do the volume of B is the one I don't know, so I'm going to put that, and the volume of A is 15 pi. Then I'm going to set that equal to the scale factor cubed, which would be 27. So equals 27. You could put over 1 if you want. And so now what you're going to do is you're going to cross multiply, and you get the volume of B equals 405 pi feet cubed. Okay, so that's how you would find that problem. Okay, so cone A and cone B are similar. The radius of cone A is 4 centimeters and the radius of cone B is 10. So there's your measurements that you can use to find the scale factor. The measurement of cone A, the volume of cone A, is 134 centimeters. So this is just like the last one. So first thing, find the scale factor. So we're going to use the radii again. This time I'm going to do A to B just because I want to show you that it doesn't make a difference. So I'm going to go A to B. My scale factor is 4 to 10, okay, which I can reduce to 2 over 5. The next thing, before I start anything else, I'm going to go ahead and find my scale factor cubed. So 2 over 5 cubed would be 8 over 125. Okay, so make sure you cube it for volume. Alrighty, so now I'm going to set up the ratio again, A to B, and you can write it over and over to remind yourself. you're going to go 8 over 125, which is your scale factor cubed, and then you're going to put your volume. So I was given A, and I was not given B, so I'm just going to put a big B. So I get 8B equals 16,750. Then I divide both, so this is the volume of B, by 8, and I get approximately 2093.8. Okay, so that is how you would find those measures. Alrighty, so now we're going to do composite solids like we did in the last one. So first thing you want to think of, do you have enough information? So do I have enough information to find the volume of the cone? I need the big B, which is pi r squared. Oh no, I don't have radius. Yes, you do, because if you look at this, the radius is the same as the one below. So I have the big B and I have my height. Okay, so I'm good to go. Do I have enough information for this one? Yes, I have big BH. The big B is pi r squared. So yes, you have enough information. Okay, so the first thing I'm going to find is the volume of the cone. Okay, so I'm going to find the volume of the cone first, and that is 1/3 times big BH. So that's 1/3. My big B is pi r squared would be 36 times the height, which is 4. So 3 goes into 36, 12 times, so that is 48 pi. Okay, and now I'm going to find the volume of my cone, volume of my cylinder, I mean, volume of the cylinder, which is just big BH, which is pi r squared, so that would be 36 pi, times the height of this one is 5, so that would be 180 pi. And now to find the volume of the composite, I would say 180 pi plus 48 pi, and that equals 228 pi, which is my final answer. That would be meters cubed, or you could calculate it out to be 716.28 meters cubed, approximately. Okay, so that is how you would find the answer for the composite. Alrighty. Okay, for this one I want you to push pause if you have a mind to, and see if you can calculate this one out by yourself, and then we'll do it together. Okay, first I want you to find the volume of the cone. So we know that volume of a cone is 1/3 big BH. Big B is the base. Here's our base. Okay, so we're going to go volume equals 1/3 times pi r squared, so that's 2 squared is 4 pi, times the height is 4. So the volume is 1/3 times 16 pi, and that would just be approximately 5 2/3 pi. Now if you want to, you could calculate that out here, and that is 16.8 inches cubed. And these are the approximate measures. This is actually the actual measure since it's in pi form. So then we're going to find the volume of the cylinder, and that one is volume equals big BH. So we're going to go volume equals, remember that the two bases are congruent, and so they have the same radius. So this would be also 4 pi, and then multiply it by the height of the cylinder, which is 5. So that is 20 pi, and that would be inches cubed, which those were up there also. And that is approximately, if you want, 62.8 inches cubed. I like waiting until I'm all done to find the measure that I'm going to get. So the volume of the cube is 523 pi, plus the volume of the cylinder is 20 pi, and that is equal to 25 2/3 pi. Now that's the exact answer, and the approximate answer would be about 79.55 inches cubed. Okay, So if these two don't add up to that, it is because you rounded earlier. And so it should be around the same if you added it together, and it wouldn't matter too much. Okay, that's it for this one. Have a great day.